Hi everyone, this is our first mathematical content video for Math 60. It's not actually the first one I recorded with math content, so I may end up repeating myself in later videos. But this is how I'll be doing my video lecture notes for the class. I prefer to use pen and paper, mostly because my handwriting is better than when I try to write using a digital tablet or something like that. And also, I will scan in these notes and post them week by week so that you can look at the physical notes as well. There are a lot of resources for learning this mathematical content. There's these videos, there's the notes that I will produce. There's also the textbook, which you can link to from D2L. And that textbook is online and also has embedded videos. So there'll be a lot of places where you can get your first look at information. So this is Math 60, General Learning Strategies for Mathematics. I don't have any notes that I'm working off of. I'm kind of just going off of the top of my head. So if I stumble or if I pause once in a while, that's just part of the process. So to learn mathematics, I like to think of it as, and this has been my experience, and it may be yours and it may not be, and that's okay. But when I started my mathematics learning, I felt like I was basically in a wilderness. Maybe there was some dark forest that I had to find my way through. Maybe there were some mountains or some rivers. And it can be pretty daunting. If you're like, first of all, I don't even know where I'm supposed to go. Am I supposed to go to the trees or the mountains or the river? How do I even get there? How long is it going to take? What do I need to know in order to be able to get there? So starting off can be pretty daunting. So my recommendation as a mathematics learner is to realize a couple things. First of all, we do start somewhere. All of you have been doing mathematics for your whole lives in one way or another, whether it's been explicit, like practicing math in your education, or whether it has been implicit, just going and shopping at the store and doing arithmetic as you're calculating out prices or building a budget or playing a game that involves thinking about angles and movement and momentum. You've all been doing math for a while, so you already have the basic skills for learning mathematics. And what I've found useful for me is to think about learning mathematics not as having to learn something new all the time, but as just expanding your knowledge little by little based on what you already know. So let's say that, when I go shopping, I'm having to do a fair amount of mental arithmetic just to keep my budget for my groceries. Well, now I've got some good understanding of how to work with both large numbers and decimal numbers. And so in this class, when we start solving equations that involve either large numbers or decimal numbers, you're going to be using a skill that you've developed, but maybe in new ways. As you learn math, you may find yourself sometimes focusing in one area more than another, and so your skill is going to grow more in that area. But it's still just going to grow little by little, and that's okay. We try to structure these math classes so that we're not asking you to learn the whole landscape at once, but to slowly build out a map of the landscape, of the mathematical landscape, so that you can navigate your way through all the different types of math that are out there. And once you find yourself reaching a mastery of one type of mathematics, and maybe at the same time, you're also learning some of this mathematics, eventually, you find you have mathematical tools that you can apply to different situations. And all of that is a part of the skills of learning mathematics. So I'll summarize this kind of as three different components. One is we have all done mathematics. We are all doing mathematics all the time. So we're not starting from zero. Which is great. Some of you may have had more formal mathematics learning than others, but I promise all of you have been using mathematics a lot throughout your lives and mathematical thinking. Two is build out your knowledge little by little by building from what you already know. So you're going to hear me, especially in class. The thing I like about meeting in class is I get to interact with you in person and actually talk about what you're doing. And you're going to hear me saying something like, oh, so we've been working, like we've already locked down that idea. We locked that down. We studied that in week one. Now we're just going to build on it a little bit now that we're in week two. Or think about it as exploring new terrain, but you're not just going to drop yourself. You're not going to start here, and I'm not going to expect you to parachute down here. We're going to build our way little by little until we've explored all of this mathematical landscape. And three, learn to transfer what you know to something new. If I feel pretty solid with arithmetic because of my grocery shopping and my budgetary planning, that's something I know I'm going to transfer it to use those ideas of working with large numbers or decimal numbers to now solving equations that involve large numbers or decimal numbers. And again, that's the idea of we're all starting from somewhere and we're building from what we know. And then when we learn something new, we're going to use it to learn more or maybe transfer it to learn something different. So these are my three general strategies for learning mathematics. Is one, to recognize that you have been doing mathematics, so you're not starting from zero. And two, remind yourself as you're learning, what is it I already know and what am I building on that knowledge? Almost everything we learn is going to be based on something that you've recently learned before. Once in a while, it may feel like we've been working towards this direction, towards a forest, and then, okay, now we're going to work this direction towards the mountains. But I'll try to be pretty clear when it's like, this is a new topic that might require you to come back to your central foundation and explore in a different direction. And when you do that, transfer what you've learned or what you know to something new. Maybe it's similar to building out your knowledge, but it can also be a little different. Math starts to be more fun, at least for me, when I realized, I learned topic A, and now in this completely different context, I get to apply that knowledge to explore topic B. All right, so those are my general learning strategies for mathematics. That's one way of looking at it. And the other way of looking at it are what I call, and many people call, the four representations of mathematical ideas. And this is also something I'm going to come back to again and again. So human beings are verbal. Most of the communication we do is through words, whether it's spoken or written. We're going to do a lot of written verbal style mathematics. However, mathematics itself can sometimes better be represented through symbols. If you think about a basic mathematical equation, like 3x plus 4 equals 9, this is a mathematical idea represented through symbols. Some symbols are for numbers, Some symbols are for mathematical operations, and some symbols are for unknown quantities. But these, I would not call these words. They are much more symbols. A lot of times mathematics focuses on this symbolic representation and forgets the fact that humans are verbal. And so if we cannot translate this symbolic information into verbal information, it's very difficult for us to understand what information is contained in here. Some ways that we do that to help us understand is recognizing that humans are also visual. Many of us, myself included, would call themselves visual learners. So pictures are worth 1,000 words. Exploring a picture can give us another way to think about it. Those of you who have studied mathematics to the point of using graphs might recognize that sometimes a graph can contain a lot of information, but organized in a way that is easier to understand. And let me give you an example of that. If I were to ask you, when is this expression minus x squared plus 20x plus 3, when is this expression at its maximum? That's a challenging question. What x value would make this mathematical expression the largest it could be? I don't know off the top of my head. I just came up with this function. I would have to do a fair amount of work. But if I gave you this picture, these are not necessarily equivalent. And I said, when is the expression represented by this graph at a maximum? You could say, oh, when the x is equal to 2, that's its highest point. Both of these pictures or both of these representations contain a lot of information, but for most humans, getting information out of a picture is a lot easier than getting it out of a formula, out of these symbols. So these are 3 of our representations: verbal, symbols, and visual. Often verbal we'll just think of as words. Mathematics is also a fairly quantitative, it's a number-heavy science. And so mathematics usually involves numbers which are very well organized by tables. And so a lot of the times we want to organize our mathematical ideas using a table of numbers. Because that can simplify the mathematical ideas. So here are 4 representations, and here's how I like to think about them and the relationships between them. And as a visual person, I like to draw a little picture. So often symbols are elevated as the most mathematical way to represent mathematical ideas. But in fact, human beings are very verbal. So I like to put that in the middle. And then we can use numbers and pictures to help us understand our different representations. And one of the key skills to build when learning and doing mathematics is not just to be able to work with all four of these representations, but to be able to go from one representation to another and vice versa. So all four of these representations can be turned into another one. And so as we work through Math 60 and later math classes, you will often be given a chance to understand a mathematical idea in all four of these different ways and to learn how to go from symbols to numbers or from pictures to verbal or from numbers to pictures, etc. Sometimes understanding symbols can be challenging, but if you can convert it to pictures, it can make it a lot easier. That's what we did here. We had a symbolic representation of an expression that was hard to understand, but when we turned it into a picture, it became very easy to understand. I'll be coming back to this idea a lot, again, especially in class as you're working through math and I'm getting a chance to talk to you. I'll probably say things like, so that's a symbolic representation, and that's challenging to understand. Have you tried converting it to a numerical representation or a graphical or a picture representation? So that ends this video. These are overarching ideas to keep in mind and to use actively, not just in this class every week, but hopefully in all your math classes and in all the time that you do math, whether it's in school or afterwards. Our next video will be a little bit of a preview of working with some of our mathematical grammar when writing expressions, simplifying expressions, and solving expressions. And after that, we'll get into section 1.1. Thanks for watching.